To understand this phase portrait, not very easy to understand. If you just read the textbook, you only see the graph, all the trajectories on the same place, but how do you draw those trajectories, right? So here I do one by one. Each one not very hard, but I show you all the details. So if you cannot follow, just let me explain more. All right, so let's do the first one. All right, so, many different types. The first type, the simplest. The first case, we consider this special case. C2 equals 0. Okay, C2 equals 0. C1 is positive. Let's consider what's the corresponding trajectory for this simple case. We can simplify our y1, y2 functions. Okay, C1, C2 terms gone. Right? We only have C1. Okay, you see, y1, y2, very simple. Okay. If you compare y1, y2, they are the same. y2 equals y1. Okay? Can you see on the plane y2 equals y1, which line corresponds to this function, y2 equals y1? Is it a straight line? That's straight line, right? Yep. y1 equals y2. 45 degree. The, this angle 45 degree. Can you see that? This angle 45 degree. Okay? That angle, right? But here we do not know the direction, the arrow direction. How can you see the arrow direction, right? From this equation, we cannot see the direction. So our next step, we want to see the, the direction in the trajectory. Okay? That's also important. All right, let's look at another level of detail. Here, I put a 1 besides that trajectory. Okay? Type 1 trajectory. All right? But we need to understand the direction. We change our hidden parameter here, hidden parameter on this graph from negative infinity to positive infinity. So look, we need to go back to the parametric curve. From negative infinity, look at the y1 value. Remember, C1 is positive number. Positive number times when t is negative infinity, this is a positive infinity, right? E function, positive, negative, negative, positive, positive infinity. So from positive infinity, y1, y2, from positive infinity to 0, is it this direction? Is it this arrow? From positive infinity, both positive infinity, then at the end, you get to the 0 point, origin point. Origin. Okay? That's the reason we draw this direction. Okay? That's type 1. All right. Type 2. Similar. We only change the C1 from positive to negative. So the equation is the same. The only difference is when we change our t from negative infinity to positive infinity, but this time C1 is negative. So negative times a positive infinity, it's a negative infinity, right? Negative infinity to origin. Okay? Negative infinity, is it here? Is it? Far down to the left, that negative infinity, right? Along this line, moving up in the slant 45-degree angle towards origin. So you see this arrow direction. Okay? All right, that's our trajectory type 2. Yeah. Can you see it in this way? Yeah? Most of you? Yeah. All right. Type 3. Yeah. Type 3. This time C1 equals 0, but C2 positive. Yeah. All right. So C1 terms all gone. So C2 terms similar, but Y1, Y2 just the opposite, right? Just the opposite. So Y2 equals negative Y1, the equation. Y2 equals negative 1, that's this straight line, okay? The angle like that straight line, yeah? All right, yeah? This time, yeah? Yeah, because look at the quadrant, the point on this straight line on second quadrant and the fourth quadrant, right? Second quadrant, X negative, Y positive, right? Yeah, yeah, because the second quadrant, X negative, Y positive. Fourth quadrant, X positive, Y negative. All right, yeah. So now let's this, look at our type 3 here, but we want to see which part of it. Okay, so let's look at the t. When t changes from negative infinity to positive infinity, negative infinity, this is a positive. Positive times C2 positive. So it's a positive infinity, and Y2 negative infinity. Positive infinity, that's positive, right? Positive, negative. So from this point, changing up towards the 0 origin. Okay? So that's the trajectory type 3. Type 3. Okay? Negative infinity to positive infinity. In that way. All right? Yeah. Type 4, C2 negative. Yeah. Same equation, but C2 negative. Yeah. And we look at t changes from negative infinity to positive infinity. But negative infinity is positive, C2 is negative. So Y1, negative infinity, Y2, positive infinity, negative, positive, second quadrant. Change from far left up, down to the origin along this slant line. Yeah. So the arrow is like this, type 4.
So it's just that half of that line.
Half the line, yeah, half that line, okay? The end point, origin, all ends up, because when we change our t, we always change from smallest to largest, okay? Negative, that's the positive direction. At the end, all ends up at the origin, okay? Origin, all right. 1, 2, 3, 4. Now, the curve part. So that's the straight line, all 4 types straight line. Now the curve type, okay? Curve type, yeah. All right. To see the curve type, we need to review rotation transformation. Rotation. Have you seen we can do rotation on coordinate system? You have XY coordinate system. Can we rotate the XY coordinate system? Have you seen things like that? Okay, yeah, so here we need to prepare ourselves a little bit, this rotation transformation. Yeah. All right. Suppose our normal XY axis, this is our standard XY axis. Oh, lagging. Yeah, lagging a lot. Yeah. All right. So now you can imagine we rotate this x, two axis, perpendicular axis, we rotate together by certain degree, number of degrees. Okay, yeah, rotate. Yeah. So you get another coordinate system, but in this way. Okay, yeah. Sometimes we want to do the rotation to view the picture equations better. Yeah. Here, because if you look at the curves, it's look like if we draw two coordinate system using these two slant lines, we can see the curve better, right? Yeah, think about that. So we want to do 45-degree rotation. Yeah. So the next question, how to do 45-degree rotation? Yeah, so here. 45-degree rotation. Yeah. Yeah, here, I noticed something, Yeah, let me pause a little bit. Yeah. I noticed something quite annoying. Yeah, because when I draw thing, my drawing slagging significantly. So do you know what's the reason? Yeah. Yeah. We do 45-degree rotation. Yeah. Because we want to use this line as the new y1 axis. That line as the new y2 axis. Okay? All right. So let me write. So this, yeah. So here you can see this line y1. Yeah. Let me use tilde axis. y2 tilde axis. Yeah. So we do the rotation. Okay. All right. So the rotation degree theta equals pi over 4, 45 degrees. Yeah. Then let's calculate the transformation formula. This is transformation formula. 45 degree, sine, cosine, pi over 2. Oh, sorry, not sine, cosine, root 2 over 2, right? Yeah. Both sine, cosine, the same number. Root 2 over 2. Okay? Root 2 over 2 here, but I multiply to the other side uv, yeah, because this is uv. All right. Yeah. Yeah. So, yeah, let me write. Yeah. All right. Because this is uv. Okay? This is uv. Yeah. But a sine, cosine, each one root 2 over 2, that's the same as 1 over root 2. I just multiply root 2 both sides, so I get this rotation formula. That's the rotation formula. Okay? Yeah. So y1 plus y2 equals root 2 times v. Okay? That's from here. See? y1 plus y2, but sine, cosine, 1 over root 2 multiplied to the v side. So root 2 times v equals y1 plus y2. Similarly, root 2 times u, this whole thing u, we multiply root 2, so you get a y1 minus y2. Okay? Yeah. That's the rotation formula. Yeah. Question? All right. This expression, okay? That expression, yeah, because that one, I want this, the u, yeah, here, all right. U, actually, I make this as the u. Oh, sorry, yeah, this is v, all right? y1 corresponds to, yeah, but because y1, y2, v, yeah, v is here, this is v, this is u, okay? That is u, yeah. y1 rotated to to u. Yeah, y1 rotated to u. y2 rotated to v. Okay, yeah. So, all right, here. All right. Again, yeah, a little confusing. All right. The formula, original formula, this is y1, y2, right? Yeah. So let me explain again. Yeah. When we look at the rotation formula, all right, this x position corresponds to our y1. This y position corresponds to our y2. Okay? That's before rotation. Before rotation, our y1, our y2. Yeah. Then we multiply rotation matrix. This is a rotation matrix. When we apply rotation matrix, we do rotation, theta rotation. Okay? Yeah. Counterclockwise. Counterclockwise, theta rotation. So the rotation result, this is rotation result. Okay? Rotation result, uv. All right? So u, the new first coordinate. Let's call, yeah, because here we do not use x, y. New first coordinate. New second coordinate. Okay? Yeah, u and a v. All right. New first coordinate, this is a new first coordinate. Okay? Yeah. New second coordinate. New second coordinate. Okay? All right. Yeah. So the formula is like this. Yeah. uv. All right. uv. Yeah. All right. So now,
so the equation you call the rotation matrix, that's the generic one
yes,
that you use to apply to your existing equations to do the rotation.
yes. Generic one applied to one point on the old coordinate system. Okay? This is x, y. It's the coordinates of one point on the old coordinate system. Okay? Old coordinate system. Then we move to new coordinate system. So this is a new coordinate system. New coordinate system, two coordinates in these two expressions. All right, that's the rotation relationship. Yeah. All right. Okay. So uv. Yeah. In old coordinate system, you just do y1, y2. You know, in this one, you calculate uv. They are the coordinate in the new coordinate system. Okay. You calculate. You find a u and a v. That should be in the new coordinate system. Okay. Like that. All right. Yeah. So a little hard to see, right? Yeah. A little hard to see. Yeah. All right. Yeah. Yeah. All right. Yeah. Let me continue. Yeah. Let me continue. Okay. So now we have this formula. New coordinate system. In new coordinate system, let's look at what's the equation for each trajectory. Okay? The trajectory we want to see, C1, C2 must be both non-zero. C1, C2, because zero, we already discussed the zero case. One of the C1, C2, zero, we discussed. So our case number 5, we want to, we want to look at both C1, C2 not zero, C1 not zero, but C2 positive. Yeah. C1 non-zero, C2 positive. Yeah. Because C1 is positive, negative, it's not important. C1 we only need a non-zero. You will see we will take square of C1. Yeah. C1 positive, negative, not important. We will take square of it. Okay? Yeah. All right. So in case number 5, let's see what is the equation for case number 5, and we draw that trajectory. We draw that trajectory. Okay? Case number 5. All right. Yeah. Yeah. All right. Yeah. So now let's look at the new new equation. Yeah. y1, y2, yeah, here. All right. Yeah. So because y1, y2 expression like that, we want to eliminate t. Yeah. We want to eliminate t. So we get a y1, y2 equation. Yeah. The question, how do you eliminate y1, y2? Okay? All right. Let me do it in this way. All right. y1 plus y2. Yeah. Let's calculate. y1 here, y2 here. If you do y1 plus y2, what do you get? y1 plus y2. You cancel out the C2 terms, right? Yeah. So y1 plus y2, you get 2 C1 e to the negative 2t, right? That's y1, y2. y1 plus y2. Okay, all right. Second, you use y1 minus y2. What do you get? This time, C1 term cancel out, right? So you get a 2 C2 e to the negative 4t, right? Okay, all right. Then, negative 2t, negative 4t, what's the relationship? Negative 2t, negative 4t. What's that relationship? Yeah, square. Good. Square. Andrew? Square. Yeah. Square. All right? So we use that square relationship, we can eliminate t terms. T terms. Okay? All right. The square, yeah, let me use the small space here. All right. Because you told me square, that actually is y1 plus y2 over 2c1. This is square of y1 minus y2 over 2. Sorry, opposite, right? Opposite. The square of the first one equals the square of the second one. How about that? Yeah, because the square of that negative 2t equals negative 4t term. Okay? So here, like that. That one, all right. y1, y2 square, is it y1, y2 square, is it 2v square over 4c1 square equals here minus, is it root 2u over 2c2? Is it that? If we use y1, y2, we use the formula here, we replace y1 plus y2 by root 2v, then we take square, so we get a 2v square over 4c1 square. Okay? Replace y1 minus y2 by root 2u over 2c. Okay? Then we simplify it. Yeah. So this, we want to simplify it. Okay? Yeah. All right. After simplification, we get this equation. V squared equals 2pu. This p represents this root 2, c1 squared over 2 times c2. Okay? Yeah. Yeah. Why I write this way? V squared equals 2pu. Why I use this form? V squared equals 2pu. Okay? Yeah. V, new coordinate system, old coordinate system. If we try to recall from the, the xy coordinate system that we are familiar, xy coordinate, x squared equals 2py. what is this equation? X squared equals 2py. What type of equation can you reckon? Oh yeah, parabola. Yeah, parabola. But you need to look at what direction parabola. Okay? Yeah. What direction of the parabola? Yeah. Yeah. Right, up. Okay? Yeah. Yeah. Because x squared equals 2pu. First, look at the p. Our p, C2 is positive, right? Our p is positive. Okay? Our p is positive. Our p is positive, so x squared equals 2py. Y must be positive, right? Because x squared is a non-negative number. Y positive, that means it's a positive direction, up. Positive direction, up. So it's a parabola opening that direction. Okay? Open up. Yeah, that direction. And similarly, when C2 equals negative, that direction. Okay? Down direction. Okay? Yeah. Down direction. Okay? Yeah. All right. So that's the 5. Number 6, C negative, so 6. Yeah, that direction. Okay? Yeah. But you may argue, yeah, so here you can look at it when t goes to negative infinity, positive infinity, yeah, because there is a square, right? So positive infinity, so you can see the arrow, yeah. So yeah, we can see one, yeah. For example, let's say case 5. Case 5, when t changes from negative infinity to infinity, okay? T negative infinity, so y1 negative infinity, yeah, because, yeah, here, negative infinity, yeah, negative, yeah, so y1 plus y2, all right. Y1 plus y2, all right, yeah, let's look at this. Y1 minus y2, okay? Yeah, from negative infinity, this is positive. Y1, so that's the, U positive big number, U positive big number, to positive infinity. So positive infinity, 0, okay? So, yeah. Yeah, but here, which way? Yeah, so here we need to see which way. Yeah, that detail. So you can see that detail. So that one or this one. That one or this one. Yeah. So UV. Yeah. This one we see, yeah, because this coordinate system, here, V is positive, right? This part, V is negative. Yeah. So let's look at here. The V part. Yeah. Y1 plus Y2. Oh, yeah. So because C1 non-zero, we need to look at is C1 positive or negative. Okay? When C1 positive, V is positive. When C1 negative, V is negative. Okay? When C1 positive, this is V positive. Yeah, here. Yeah. So let me draw this. This part corresponds to the C1 positive. This part corresponds to C1 negative. Okay? C1 negative, but you from negative infinity to positive infinity in this direction. That direction. Okay? Yeah. Similarly for number 6, the same way. Yeah. So this time we need to look at the C1 positive and negative. Okay? Yeah. Then we look at from the coordinate system. Yeah. Yeah. It is a little hard. Yeah. It is a little hard. Yeah. Quite hard. Yeah. Little hard. But here, the bottom line, you only need to know we can figure out. Okay? Yeah. We have some specific ways we can figure out the trajectory. Yeah, first, how to draw the trajectory. Second, how to draw the, direction. Yeah. Direction on the trajectory. Okay? Yeah. Yeah. It's a little hard. Yeah. Try your best to understand. Yeah. Yeah. Try your best to understand. Yeah. Although I can avoid questions for this part, I can avoid. Yeah. But you just learn, if you want to explore this kind of information, you can do it. Okay? Yeah. Yeah. Here, another thing is, because here I try to, so why I talk about things like this so complicated, right? Yeah, actually the textbook skip the details here. It just draw the graphs. It does not explain. But because at this point, we always do computation, right? Yeah. We didn't do graphing. We didn't draw graphs. We always do computation. Yeah. So that's something I feel you need to learn how to draw graphs. Okay? At least you need to know a little bit. Yeah. If you do not know how to draw graphs, that's a missing piece of your whole knowledge picture. Okay? Yeah. So you have a missing piece. Graph part. Yeah. So here, yeah. Although it's a little complicated. Yeah. All right, so let me continue. Let me continue. Now, because here, one big reason, so here I see the reason this part is so hard, and one big, you're not familiar with that rotation operation, right? Yeah. Most of you do not feel comfortable on the rotation operation. Coordinate system, you do rotation, then you get lost. That's the biggest reason. Rotation. Yeah. Okay. When you learn physics, do you need to change your, coordinate system frequently? Yeah. As I know, so you need to change your coordinate system. Moving your coordinate system, right? To a good place. Yeah. Translation, rotation. These two basic operations. Yeah. Translation easy, yeah, but rotation a little hard. Yeah. All right. Yeah. Next, D.2, 5 types of critical points. Yeah. Critical points. Yeah. So here we talk about critical points. The meaning of critical point here is different from your calculus critical points. Calculus, you have a critical points, right? Yeah, but it's different. Calculus, when you draw a curve at the point the derivative equals 0, that's the critical point. Yeah? Derivative equals 0. Okay, but here partially, so we have something 0, but the meaning is quite different. Critical points of the system. So let's make our observation. The point, origin point, y equals 0, origin point is a common point of all trajectories. All, okay? Yeah. So you can see that origin in this picture, so special, right? So special, okay? So we want to study the special point. Its property. Yeah. Right. How to interpret this phenomenon? This special point. All the trajectories, all end up at this point. Okay? Yeah. When t t is at infinity, positive infinity, or at origin. Yeah. You can see. Yeah. All right. So at this point, there is no tangent line that can be defined for all trajectories. Yeah, because this line, yeah. So many trajectories. How do you draw tangent line? How do you, because it's hard to define tangent line at this point. Yeah. The slope of the tangent line cannot be defined. Yeah. What is the slope of the tangent line at this point? You cannot define it. Yeah. If it is well defined, then which trajectory has the tangent with the slope at this point? So you cannot. Yeah. So all these trajectories, if there is a specific slope number here, it should be the tangent of which trajectory, right? Yeah. So it's very, very hard to see that. Yeah. All right. If we look at the equation, we write because the, homogeneous system is like that. If we write this, it's homogeneous linear system, and we use the parametric curve for each trajectory, we have the parametric curve equation like this. Yeah, y1, y2. Yeah, y1, y2. Now, we want to calculate the slope of this parametric curve at t. Do you know how to calculate the slope of the trajectory, this curve, at the point t? Yeah. Think about that. Yeah. Here, let me draw graphs here. Okay. All right. Yeah. All right. So suppose here I draw one trajectory. Okay. Yeah. This is one trajectory. The curve. Okay. x1, x2. All right. Now we want to draw a tangent line at point t. The question: how to calculate the slope? How to calculate the slope of this tangent line? Okay? Yeah. Tangent, because what's the slope? Slope is the tangent theta, right? Tangent theta. Tangent theta. Okay? Tangent, we know the definition of tangent. Yeah. The opposite side over adjacent side, right? Definition of tangent, opposite side over tangent side, over adjacent side. Yeah. Opposite side here over adjacent side. Okay? That's the slope definition. Opposite over adjacent. Okay? All right. The tangent. But what's the opposite? How do we represent the opposite? Tangent theta, opposite. Okay? All right. Remember, our coordinate system. Here we are in the y1, y2 coordinate system. Yeah. y1, y2 coordinate system. Okay? Yeah. So the tangent, the opposite vertical direction, horizontal direction y1, vertical direction y2. Okay? Yeah. What's the direction of the opposite side? Opposite. What's the direction of the opposite side? Y2. Yeah. Y2 direction. Okay? Yeah, opposite side, y2. So we use dy2, differential. Because when we want to find agent, it should be very small, right? So we use d, differential. The opposite side we use differential. Okay? The vertical direction, so we use d2, dy2, not dy1. Okay, all right. Adjacent horizontal direction, right? Adjacent horizontal direction, so we use dy1. Okay? That's the definition of slope. Okay? So here, from this, that's the basic definition of the slope. Okay? Yeah. So it's generic. Yeah. It's always true. Always true. For any t, it's always true. Yeah. Everywhere. Okay? All right. Now, based on this definition, let us calculate the slope at the critical point. Yeah. So that special, origin, this critical point. Yeah. Later we will say critical point. All right. Slope. Let's do the calculation. Slope. Slope equals dy2 over dy1. Yeah. Then, what is dy2? Yeah. dy2. Look at here. What's the dy2? dy2, dy1. This is the y2 equation. y1 equation. dy2. Yeah. So let me write one more step. One more step. dy2, is it y2 prime times dt based on the y2 function? The relationship between differential and the derivative. So dy2 equals y2 prime times dt. The variable dt. What is dy1? dy1 equals y1 prime times dt. How about that? Okay? Yeah. How about that? All right. All right. Yeah. So, but dt cancel out, right? When you take a ratio, the same dt differential cancel out. So you only have y2 prime over y1 prime. How about that? y2 prime over y1 prime. dt is gone. Okay? Cancel out. Yeah. So the derivative, but y2 prime, what is y2 prime? We need to calculate y2 prime. Okay? y2 prime from there. y2 prime. Okay? Sorry. y2 prime. Yeah. That is y2 prime. Okay? y2 prime, y1 prime. Yeah. Yeah. Equals expression you can write here. Okay? You can write expression here, all right? So y2 prime, y2 prime, y1 prime, right? Yeah. Yeah. After matrix multiplication, y2 prime, y1 prime. Okay? So you take y2 prime over y1 prime. Yeah. So the slope equals y2 prime over y1 prime. All right? Yeah. All right. So now the problem. At the origin, is this fraction defined at origin? Origin means y1 0, y2 0. y1 0, y2 0. Is this fraction defined? Yeah. It's not defined. Okay? So it is undetermined, yeah, because this expression, the slope expression at the origin is not defined. Okay? No value can be used here. All right. So when you have this special situation, this point is called a critical point. Yeah. Its slope is not defined. The slope of any trajectory at this point is not defined. Yeah. Yeah. Any trajectory, yeah, because any trajectory you have this a1, little a1, numbers, coefficients, but you cannot get a valid number for the slope. Yeah. d2 dy2 over dy1. So it's undefined. So it's a critical point. Yeah. That's the definition of this critical point. Yeah. And you may have several critical points. You know. Here we just look at one. Yeah. Yeah. It's possible, you know, given a differential ODE, given an ODE, you know, you may have several critical points. Yeah. So we need to study those critical points one by one. Every time we study one critical point. Okay? Yeah. So then next one, you know, another one. Yeah. Yeah. Critical point. Okay? Yeah. So we study the behavior, trajectory behavior around that critical point. Yeah. All right. Yeah, this part a little hard. Yeah. A little hard. Yeah, but your knowledge, so you need that piece knowledge. Yeah. The piece of the puzzle. Okay. Yeah. Missing piece. Yeah. Yeah. Here we try to practice. Okay. Yeah. So the graphing part a little weak, so we try to, you know, get better. Every time when we work on this topic, we try to get a little better. Yeah. Yeah. Today, I think the hardest part is that rotation. The hardest part. Yeah. Yeah. Rotation. Okay? Yeah. All right. Okay, so let's stop right here. Yeah.